Breaking news! An improvised explosive device has been set off by none other than a terrorist mastermind, Wile E. Coyote, in an evil scheme to slaughter the last of the endangered roadrunners. We have no real facts at this point, but we're going to go ahead and report that at least 4 billion people have died in this explosion. And the roadrunner may or may not have been taking supplemental drugs. These wacky antics in real time are completely unnecessary, and only calculus is needed to prove it. Now, the boys in the studio have hooked us up with a couple of numbers that we can use for this occasion. You see, while the Coyote's top speed is 43 miles per hour and the Roadrunner's is only 20 miles per hour, there's still a reason that the Roadrunner wins. See, the boys have hooked us up with a velocity function that shows that the Roadrunner's velocity, when his top speed does not exceed 20 miles an hour, is 6x squared, x being the amount of foot travel that he makes to go that far. And the Coyote's is only 3x squared. Now, if you take the derivatives of each of those, you can find the acceleration functions, and you'll see that the Roadrunner's acceleration function is modeled with 12x, where the Coyote's is only 6x, meaning that at any step the Coyote takes, the Roadrunner is already 2 steps ahead of him. But with their top speeds, in the long run, the Coyote would win, and that is why the Roadrunner always resorts to wacky antics such as drawing paintings on all sorts of boulders and tricking him in all sorts of ways that only a Coyote could be tricked. Now, if you look behind us, you can see some of the least mangled corpses. As they appear to be laying in the sun, they're not actually laying in the sun, they are dying, and it's awful. And only after we show the Roadrunner this calculus will he be able to catch that bird and maybe save a couple of lives along the way. Oh, look at that one. That one's gross. Ugh. Oh, they're so gross.
Oh, they stink.
Ew, ew, ew. That's nasty. That is just awful. That is awful. Now, if you look in the pockets of these people, you can definitely find a wallet full of money. More on this terror plot later, even though I've pretty much already explained it. Now, it's on to...
Breaking news. This is Darla Derivative with CALC News. A car crashed into the Integral Institute this morning. Sometime within the interval of 2 to 4 a.m. Police say the velocity of the car at the time of collision was shown by the equation f of x equals 3x plus 2 over x. By using the quotient rule, you can take the derivative of the velocity to find the speed of the car at the time of collision. Low D high minus high D low over low low. So at time 1, the speed would be 2, which means at time 50, the car would have been traveling at 100 miles per hour.
This is Shy Pie reporting from CALC News. It's getting really windy outside right now. There's gonna be a tornado coming pretty soon. It's gonna be bigger than the movie Twister. Oh no! The wind! It's taking the umbrella!
Please wait, we are having technical difficulties.
Okay, this is a graphic representation of the tornado. We're gonna do it with volume and that. You do pi and the integral from 0 to 200, then the top minus the bottom, dx, and then when you take the integral of it, you get this. You put 200 on top, 0 on the bottom, and then when you plug it all in and put it through the calculator, it equals 16,756,417.46 feet cubed. And that's like bigger than the United States.
Breaking news! This is Samantha Summary reporting live at Infinityville's first annual marathon. And I'm reporting from CALC News. It is a gorgeous day out running, as you see, with all your marvelous runners. And so, we are trying to figure out today how many runners have reached each mile marker between the 5-mile marker and the 13-mile marker. Alright, so, a Riemann sum is drawn by drawing your simple chart with the
Intervals.
with their intervals at the bottom and your times, or people in this case, at the top, drawn in 4 sub-intervals. Alright? So, out of your 4 sub-intervals, we are trying to figure out how many people are running. So here's your work. You see, at the zero mark, there are no people running because nobody can run a mile in 0 minutes. Because that is impossible. Alright, so we are doing a right Riemann sum. So what you do, you take your numbers, or your people, and you multiply them by the numbers at the bottom, which is your interval. So you have 0 times 30 plus 5 plus 28, 5 times 28, plus 2 times 25 plus 3 times 20. And it is 5 and 2 plus 3 because there are that many in between each number on the interval here. And altogether, you have 250 people running in between each interval. And that is your news. Cooking news are next.
Okay. Good morning, guys. This is Related Ray, and as we all know, we are days away from summer break, and everyone's going to start having parties and cookouts, and one of the best side dishes is some cookies. So today I'm going to show you how to calculate the rate at which cookies grow in the oven using related rates. So, as we have our cookies, the area is going to be 25 pi, and the rate at which a cookie grows in the oven is 2 centimeters per minute. So, knowing this, we need to find the radius of a cookie. Therefore, we're going to have A equals pi r squared, which is going to equal 25 pi, because this is our area of the cookie when they come out of the oven. To find our radius, so we are going to divide by pi, which will cancel out this pi and this pi, so we're left with r squared equals 25. Then we take the square root, and your r is going to equal plus or minus 25, but for this it's just 5. So that is our radius, so we put that over here. Our next equation, using more related rates, you have dA over dt equals 2 pi r dr over dt. We don't know dA over dt yet, but we do know our radius, which is 5, and then our change between radius and time is over here, which is 2 centimeters per minute. So it is just 2. And then when you solve it, you're going to get dA over dt, which equals 20 pi. And this means that the area of the cookie is going to increase at 20 pi per minute, centimeters per minute. And that will give you the area of the cookie at 25 pi square centimeters at the end of the 8 minutes in the recipe.